We've talked about Fibonacci's Book of Squares, and we've showed the relationship that Fibonacci wrote about between the sequence of odd numbers and the sequence of squares. Well, as it turns out, Fibonacci has a sequence of numbers named after him called the Fibonacci sequence, and let's take a look at it. The Fibonacci sequence looks like this. The first number is a 1, the second number is a 1, the third number is 2, the fourth number is 3, and the fifth number in the Fibonacci sequence is 5. And the sequence continues on in that pattern forever. Now, you can look at this sequence right here and try to decide what's the best number to come next, what do you think it's going to be. And I just want to point out again that when you're doing that, you're using what's called inductive reasoning, and you're actually doing mathematics. And when you're in that state of mind, it's actually a very pleasant experience. You don't notice yourself as being separate from your surroundings. You don't notice time going by. It's actually a very pleasant experience to do that, doing mathematics. It's only when you come out of that and try to kind of evaluate how you've done, maybe you compare yourself with other people or whatever, that you put some kind of value on it. Maybe you feel good about it or bad about it. But the actual experience itself is a pleasant experience. Okay, so 1, 1, 2, 3, 5, that's the beginning of the Fibonacci sequence. Next number in the sequence, what do you think? How about 8? The number after that, 13. The number after that, 21. So if you're getting those right along with me, then you've recognized the pattern that I wrote with the first few numbers in the Fibonacci sequence, which is this. It starts with a 1, the next number is a 1, then after that, to get the next number, you'll always add the two numbers that came before that. So 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 3 and 5 is 8, so on and so forth. So that's recognizing the pattern that exists in the Fibonacci sequence. So it turns out that this sequence of numbers has all kinds of applications. It describes all kinds of things in the world that we see around us. I'd like to point out one thing to begin with is that if you read the Da Vinci Code, you know that one of the first clues given in the Da Vinci Code is this right here, 13, 3, 2, 21, 1, 1, 8, 5, a scrambled version of the Fibonacci sequence. So if you had known the Fibonacci sequence when you read the Da Vinci Code and you saw this first clue, you might recognize it as a scrambled version of the Fibonacci sequence. 1, 1, 2, 3, then 5, then 8, then 13, 21. So that first clue in the Da Vinci Code was the Fibonacci sequence. One of my favorite applications of the Fibonacci sequence is in counting the number of bees in each generation of the family tree of a male honeybee. Male honeybees are interesting because they come from unfertilized eggs. They have only one parent, their mother. Female honeybees come from fertilized eggs, so they have two parents, a mother and a father, or a male and a female. So if we look at the family tree of a male honeybee, I'll write the male honeybee like this. That male honeybee has only one parent, its mother, because it comes from an unfertilized egg. So that male honeybee has one parent, its mother. Now that female comes from a fertilized egg, so it has two parents, a female and a male. That female has two parents, a female and a male, and that male has only one parent, a female. Now if I look at each generation in the family tree of a male honeybee and I count the number of bees, this is what I end up with. 1 bee in that generation, 2 bees in that generation, 3 bees in that generation. Looks like it's the start of the Fibonacci sequence. Let's go one more generation. That female has two parents, a female and a male. That male has only one parent, a female. That female has two parents, a female and a male. So the number of bees in that generation of the family tree of this male honeybee is, just like we thought, 5. And if you go to the next generation, you'll get 8. The generation after that, 13, so on and so forth. The number of bees in each generation of the family tree of a male honeybee follows the Fibonacci sequence exactly. So I just wanted to show you a sequence of numbers that's named after the mathematician Fibonacci. He wrote about it in one of his books that he was writing around 1225.